Method Cybersecurity Limited is a business unit of Method Safety and Security Group. We provide training in security awareness and cybersecurity risk management for developers and end users of operational technology. We also provide cybersecurity risk assessment services for clients' operational technology assets and networks, both as a retrospective review of existing control systems and as part of the hazard and risk assessment process for control systems at the design stage. Safety and security are broadly synonymous in their dictionary definitions. Both are emergent properties of a system resulting in the freedom from harm. In the process industries, controls and safety systems are designed and implemented to perform reliably, consistently, and predictably when expected to do so. But if a system isn't secure, you can't rely on it to be safe. Unfortunately, the risk assessment methods familiar in the process safety and functional safety life cycles, being based on the probability of equipment failures, don't take deliberate maloperation of a control system into account. Consider it as a game of cards. From the safety perspective, you expect the other players to be honest. You know that there are only 52 cards in the pack, so you can calculate probabilities to inform your decisions. Security, on the other hand, has to take into account the malicious and creative nature of humans. You can expect the other players to be dishonest. You can expect them to improve their hand by adding extra cards in order to win. So we can only say that some outcomes are more likely than others, but likelihood does not give us a usable probability value. So, what sort of equipment are we talking about today? This representation of the Purdue reference architecture shows the relationships between industrial control systems, bounded by the red dotted line, and corporate networks, or the traditional IT infrastructure. It also shows the typical equipment types found in each level. While you'll recognize a lot of IT hardware such as engineering workstation PCs and plant HMIs running Windows operating systems in levels 3, 2, and even level 1 of the OT environment, the purpose of IT and OT systems are very different. IT is business focused, focuses on data. OT is process oriented and focuses on control of physical equipment. IT systems are interconnected, non-autonomous, and run common software. OT systems are generally far less connected, operate with a high degree of autonomy, and run proprietary software. IT hardware and software are constantly changing and developing. OT tends to have far longer development cycles. IT software is simple to patch. Frequently it's an automatic process. Patching OT systems generally requires significant production downtime for integration and testing of patches. IT operates solely in the cyber domain, whereas OT manages real-world physical processes. Cyber attacks on IT systems can be costly to a company and time-consuming to recover from. But what if the attack isn't targeted at information, but at the cyber-physical boundary? Attacks on operational technology systems have the potential to cause physical harm to operators and damage to equipment, just by subverting the normal operation of process control or safety systems in order to make them fail or operate in ways not intended by their designers. So while a bad day in IT security could lead to loss of data, money, and corporate reputation, a bad day in OT security could lead to loss of life. While still less widespread and less financially damaging than cyber attacks against corporate IT systems, attacks on industrial control systems have been increasing in number and complexity over the past decade. From the Stuxnet attack in 2010 through to a series of attacks against the Ukrainian electrical grid, the second of which, in 2016, showed that the attackers had gained an understanding of industrial control system protocols, and the Trisis attack of 2017, which was the first malware to target a safety instrumented system controller. Then through to the present day with malware including Indestroyer v2 and Pipedream, which are sophisticated modular platforms capable of deploying custom configured payloads against any major industrial control system vendor's hardware. These, however, are the big headline attacks over the past decade. Each one of these would have required a large amount of skill and huge resources to develop. However, as the majority of attacks on OT start in the IT environment, you can't rule out low skill level attacks such as ransomware being able to impact your company's OT. The start of an attack could be as simple as a process operator clicking a link on a phishing email or revealing their login credentials. The 2017 Trisis malware is worth focusing on because, while it wasn't the most damaging OT attack, caused a lot of concern as it directly targeted a last line of defense safety system, and it was discovered entirely by accident. The target was a Saudi Arabia-based refining company, and the attack was launched via an infected workstation PC attached to a Schneider Electric Triconex safety instrumented system. The attack, named Trisis, or Hatman, or Triton, by various security analysts, was only discovered because a possible error by the attackers caused the system's integrity checking logic to go into fault, which shut the plant down safely. Further investigation revealed that the attackers had been in the control system for several months, with an earlier shutdown incident in June of 2017 being misidentified as an equipment failure rather than as a cyber attack. In all, 6 of the site's critical safety systems had been compromised. And although this slide shows an unexpected plant shutdown as a possible endpoint for the attack, it's highly unlikely that this was the aim of the group behind Trisis. You don't expend that amount of time and skill just to cause production delays. In the years since the Trisis attack, threat analysts have seen a steady increase in the amount of malware and attacks targeting OT and safety systems, with malicious code, once the preserve of advanced and well-resourced adversaries, now sold as a service to less skilled attackers. But what makes industrial control systems a target for attack? A significant proportion of OT equipment is old, and much of it was not originally designed with security in mind. Given the time taken to develop control system products and bring them to market, even new hardware and software will be lagging behind the constantly evolving threat landscape. The ever-increasing business requirements for access to operational data have resulted in more OT systems being accessible from corporate IT networks or remote connections. Many OT systems are unpatched or unpatchable, either because this would cause unacceptable production downtime or because it could cause the systems to become incompatible with the items that they control. Process industry OT systems and networks often grow and evolve over time, rather than having been designed as a single system, up to the point that often even the system owners don't fully understand the extent of their control hardware and its interconnections. All software has flaws, and not all flaws may be discovered by testing. Most control and safety systems are built on complex proprietary software your company has no visibility of or control over. Exploitation of vulnerabilities in equipment's vendor code, termed supply chain attacks, is becoming a significant concern for OT operators. Securing digital technology can be a daunting task when you consider that the defender has to be successful against every attack, whereas the attacker only has to be successful once in order to establish a foothold in your control systems. There are many useful standards and guides to outline how companies should approach cybersecurity, including the IACS 62443 series of standards, and the UK Health and Safety Executive's OG86 guidance document on cybersecurity for industrial automation and control systems. Most, however, advise the following common sense steps which can be incorporated into a company's procedures and practices. Train your staff. Humans are still the single biggest vulnerability in automated systems, and the entry point for most cyber attacks. So well-trained employees are a critical line of defense. Make sure your staff understand their security responsibilities and how to detect and respond to security breaches. Identify your assets, hardware, software, and configurations. You can't defend what you don't know you have. Identify the extent of your most valuable systems. These are the crown jewels, the systems which would cause a really bad day if you lost visibility or control of them. It's also critical to understand how they interface or communicate with other and external systems. There's no value to locking the front door if the back door is left open. Apply appropriate security measures based on an understanding of the risk to your organization. This will allow you to prioritize your security effort and expenditure. Implement security measures in multiple layers, as you would with safety systems, in order to provide defense in depth. Be aware that the threat landscape is constantly changing. Keep your finger on the pulse of security threats and vulnerabilities. There are many free online resources reporting discovered vulnerabilities, current news, and trends in operational technology cybersecurity. Understand that compromise may happen, so make detection easy. Design your process and security controls to alert you if anything goes wrong or changes unexpectedly. Have a business continuity disaster recovery plan, not just a data backup. Create a procedure for responses to an attack. Outline individual responsibilities. Practice the plan regularly and update it frequently. Be aware that the attacker may not be an unknown outsider. Train your staff to recognize insider threats and limit access rights to critical systems using the principles of least access and least privilege. An operator's access should be sufficient to carry out their work, but no more. Finally, do not overlook physical security. Subverting a safety system could be as easy as removing a sensor or blocking a relief valve if an attacker can gain access to your plant. So if I can leave you with a final thought for the day. Developing these concepts into a frequently practiced, reviewed and updated cybersecurity risk management policy and procedures, while it may not stop attacks, it will help keep your OT safe and secure.